except this was by an Italian, Giuseppe Piazzi, except the next year they found another one. Heinrich Olbers, the guy who's famous for Olbers' paradox, why is the night sky dark, found one. Then they found another one. Then they found another one. They realized, hey, wait a minute, there's a whole bunch of little planets there. And that was the asteroids. And of the four big ones, there's only four big ones and thousands of little ones, two of the four are passing close together tonight in the constellation Virgo.
So,
Absolutely.
Paul, this is a big deal at our observatory because we've got these two asteroid and a minor planet together, right?
We've got them in the same field of view. So now's a great opportunity. We'll show viewers some animations that I made earlier, which will show them which of these white dots are the asteroids. And if we can bring those up now, if our producer can bring those up, we've got an added treat tonight, Jeff. We've got both Vesta and Ceres in the same field of view in our half-meter telescope as a galaxy cluster. It's absolutely beautiful. Hopefully we can pull these images up fairly soon, and I can point out to you which of the objects is Vesta and Ceres. While we wait for those, Bob, there's a huge confusion, isn't there, between all of this terminology, between a dwarf planet, a minor planet, near-Earth object, near-Earth asteroid, comet. Can you give us a little bit of clarity on some of those definitions?
For the old days, Paul, when everything was simple and these were simply called asteroids, meaning looking like stars.
I'm going to interrupt. I'm going to interrupt
yes.
Because we've got these animations that I made just a couple of hours ago. So these are from the live images. And when we go to the live images, when we start talking about this in more detail, you can see the two dots that we're looking at, the dwarf planet Ceres and the asteroid Vesta. And these two Slooh members have been watching these two, Bob, getting closer and closer together every night. Now, we've got an absolute treat. We're going to be looking at images from the half-meter telescope now. So if we can flick over to that image, because we've got still Ceres and Vesta showing up, moving across the field of view of the telescope, getting closer and closer. But if you have a look at the bottom of those images, you're going to see that both asteroids are heading straight towards a beautiful galaxy cluster. And this is just a coincidence, an absolute coincidence. So our producer will get that up while Bob and I talk a little bit more. You can watch the live images coming from the half-meter telescope at the Slooh Canary Islands Observatory. Bob, when I was reading up about this, these are two of the brightest asteroids, dwarf planets. You're going to explain that in a sec. You said at the beginning of the show this is historic. The last time these two objects were this close together in the sky, telescopes hadn't been invented, had they?
No, this is just absolutely amazing. And what you've done here, showing them as they were a little bit earlier tonight, speeding towards a distant galaxy cluster, so many, I don't want to be unscientific, but zillions of times farther away. Just beautiful. Yeah. Vesta is the brightest of the asteroids. Maybe I should back up and talk about the name. Yeah, they started to be called asteroids because astra means like a star, and they look star-like, even through the Slooh telescopes. No matter what telescope you use, they're going to look like dots. But some years ago, it was decided when Pluto was demoted, we're going to talk about that much later when we get to Pluto, which is also reaching its closest tonight. We're going to get to that later, that the Pluto and Ceres both are round. They're balls, and all the other asteroids don't have enough mass to them to be spherical. So rather than call it an asteroid, Ceres is now officially called a dwarf planet. But who calls it that? Nobody. If you talk to astronomers and say, what is Ceres? They'll say, oh, Ceres is an asteroid, the very first asteroid. In fact, the biggest of the asteroid. It's about 600 miles across. Compared to that, Vesta, which was discovered a few years later and is the brightest asteroid because it's the same color as vanilla ice cream. It's the only white asteroid.
Let me cut in there, because you said Ceres is the brightest asteroid, and our producer's going to cut.
No, biggest asteroid.
Right. Sorry, biggest.
Ceres is the
Because
biggest. Vesta is the brightest.
absolutely, and that's one of the things that we had a question about tonight, because the images that we're seeing tonight, we're going to go to the live images any second now, but viewers will see that Ceres is actually slightly fainter than Vesta. So why is that when Ceres is so much bigger?
Fascinating. Ceres is about 600 miles across. Vesta is only 300, and yet Vesta is brighter. So bright that sometimes it can be faintly seen by the naked eye. I've seen it in the dark skies here near where I live without any telescopic or even binocular equipment at all. Why? Because Vesta's the only asteroid.
Let me, as your meteorologist, let me answer this one and see if I'm right. High
Go ahead.
albedo. Is that a higher albedo, right?
Exactly. Albedo is our fancy schmancy term for reflectivity. An albedo of 1 would be it reflects all the light that hits it. Not even mirrors do that. Mirrors reflect about 96% of the light that hits them. But snow has an albedo of about 90. Very reflective. Coal has an albedo of about 5. Reflects only 5% of the light that hits it. So that's the answer, Jeff, that Vesta is a very high albedo. It's about the same brightness as vanilla ice cream. So there's our vanilla ice cream asteroid on the lower right and our chocolate one on the upper left. And that accounts for the difference in the brightnesses. But hey, of the 4, there's only 4 big asteroids. Well, the 5th asteroid is a little bit big too. And 2 of them are meeting tonight in the constellation Virgo, which has more galaxies than any other constellation. So there it is. There are some galaxies far in the background. This is so cool.
I'm counting at least 6 there, Bob. There are the 2. Now, this image, if our producer can stay on this live image, this is coming direct from the half-meter telescope in the Canary Islands. So you've got, as Bob's just said, Ceres is the top brighter object, Vesta's to the right, but lower down you can see these 2 smudgy patches, and as the image builds, you're going to see that the top one of those is a spiral galaxy, but the galaxy just below that, you'll see it's got these kind of 2 little wispy tails coming off it. That's a spiral as well, but it's just tilted slightly more towards us. But all of the smudgy looking objects to the left hand corner of that object, isn't the telescope out of focus? Those are all galaxies. Bob, I don't think we've ever had a live show where we've been seeing so many galaxies live.
No, it's gorgeous.
It's just such
it's
a bonus.
so gorgeous. And to see this historic moment when we've got 2 of the largest asteroids, in fact, the largest is Ceres on the top, the largest ever, passing in front of whole bunches of distant galaxies. Gorgeous. Man, is this great. And this is live, of course.
As long as we're doing this, and as long as we're looking at this live, I think a lot of people would like to know Paul, and Paul is our observatory director, so he's exactly the right guy to ask. What is it that we're looking, or how are we able to put this image on the screen for people to see? What are we looking through, and is this what our Slooh members see when they use the telescopes?
That's right. Jeff, we haven't really said what Slooh is too much or how people use it. Yeah, this is a mission which is set up by a Slooh member, and they point the telescope to where they want it to point to. We've asked everybody in this period for the show to point it at Ceres and Vesta, and a little later Pluto as well. So basically people can sit from their home in the comfort of their own armchair, even if they've got clouds overhead, and they can control these telescopes, which are in the Canary Islands. It's at this high altitude site just off the west coast of Africa, which is actually ideal timing because obviously it's dark there now, whereas for people in the US, it's still daylight there. So you haven't got to stay up late to do astronomy. And people control these telescopes to point them wherever they want. In fact, we've got a question coming up later, and we're going to show some of the other images that some of the Slooh members have been controlling the telescopes for earlier on tonight, Jeff. So
all right,
make sure people stay around for that, because they are glorious color images.
And if you are interested in these images, and obviously if you're watching, you really should take the time and go to our website at slooh.com. Let me spell that for you, because it's not a common spelling, SLOOH.com. And just look around, and you'll see why so many people have decided to become Slooh members. Also, as long as you're doing that, you might as well sign up for our email alerts. Go to live.slooh.com. No www, that's live.slooh.com, and sign up for email alerts so that anytime we're doing one of these broadcasts where we're going to be featuring some objects in the nighttime sky and showing them with Slooh, and having our experts, Bob and Paul and other Slooh experts, come on and explain it, then you'll be tipped off before that comes on. So sign up for the alerts. Go look and see if becoming a Slooh member is an idea for you. Now, Paul, you said this is from one of our 2 telescopes in the Canary Islands, this image we're looking at right now?
Yeah, this is from the half-meter telescope. Now, anybody who knows anything about telescopes knows that a half-meter telescope is worth tens of thousands of dollars and is a wonderful, wonderful instrument. But it's not just the size of the telescope. What you have to equip that telescope with to take images like this are kind of scientific-grade CCD cameras, because we're looking at galaxies which are, Bob, millions of light years away?
Yes. Yes, tens of millions.
So to capture the little photons that are from these incredibly faint objects in the sky, you have to have incredibly sensitive cameras, and that's what the CCD cameras do. This camera that's taking this live image at the moment, those 2 galaxies have just come into color. By the way, there's a little bit of green in the images tonight. That's because we've got a bit of moonlight washing over these images. But that camera is currently operating at minus 40 degrees C. And it has to be really cool to stop the noise and stuff like that. But it's basically, Jeff, technology that you can't afford to buy yourself. So Slooh members get to use this and point it wherever they want. And people, it's worthwhile just adding this before we go on to the Pluto segment, that a lot of people are a little bit kind of put off, because astronomy can appear a really daunting subject when you first start off in it. You don't need to know anything about astronomy to actually use the telescopes on your very first night, because you can pick an object from a list. It'll only pick objects that are visible, or you can set up coordinate missions and go searching for comets and supernovae and stuff like that. But let's get back to tonight while we are looking at this fabulous live image of Ceres and Vesta both approaching. You'll see them as each image comes up. They're slightly moving down towards the left-hand corner, and they're moving towards this glorious galaxy cluster. Cluster of galaxies, absolutely beautiful. But Bob, we're going to move on now, aren't we, to talk a little bit about Pluto. But I didn't let you finish off what you were telling us about the terminology and some of the mixed terminology. Now's a good time to do that, isn't it, when we talk about Pluto, because Pluto was discovered as a planet, but it's no longer a planet.
Yes, and even before that, these poor asteroids, when they were first found, we thought they were planets when Ceres was first found, and then Pallas and Juno, and then Vesta, which was the 4th one found. And then, by the way, none were found again until 1845. We're talking about almost a human lifetime passed before more were found, and then people started realizing, whoa, there's a lot of these guys there. So instead of planets, we started calling them asteroids. Aster means star-like, because they're just little dots, and they are small. The largest Ceres is only about 600 miles across. Well, that wasn't good enough. Then they started to be called minor planets instead of just asteroids, and that became the official name. And we still haven't left well enough alone, because now we're starting to fool with that too. And Ceres has been officially classified as a dwarf planet. So what is it? A minor planet? An asteroid? A dwarf planet? The truth is, you can call Ceres any one of those things, and no astronomer will take you to task for it. And Pluto, as for Pluto, that's, yes?
I was going to say, so these are not hard and fast, like for instance, there's a hurricane off the east coast of the United States tonight. We know once this storm got over 74 miles an hour, it went from a tropical storm to a hurricane. It's a very well-defined delineation between the two. It's a little bit more fuzzy when it comes to the difference between an asteroid and a minor planet, right?
Well,
or am
no,
I
they mean the
misreading
same
this?
thing. No, asteroid and minor planet mean exactly the same thing, like woodchuck and groundhog. Two names for the same thing. Dwarf
Right.
planet, that just started in 2006 when we decided that anything that's a certain mass and is spheroidal and has a few other qualities, like Pluto, is going to be called a dwarf planet. Did I segue, Paul, properly into
Yeah,
Pluto
let's
now?
talk about Pluto, guys, because that is
You did.
that is the forgotten child of of our solar system. It's been demoted.
Yes, yes. And what we've got with Pluto is, first of all, the farthest planet, or is it? It was closer to us than Neptune from a period of time from the late 80s until almost the year 2000. Right now it's heading away from us, but once a year it comes to its closest point, and that is tonight. Tonight is the night of Pluto's
is.
opposition. It was actually closest 2 nights ago, but opposition means it's now lined up with the sun and the earth in a straight line. And we're very excited about it because the New Horizons spacecraft, which has been en route to Pluto and will have traveled 8 years before it arrives finally next July, exactly a year from now, will suddenly make this tiny object, only 1,400 miles in diameter, barely half the size of our moon, will suddenly turn it into a world. So this is the last time, gentlemen, that we are looking at Pluto in the traditional way, seeing it as the little dot that it is before it has an actual picture and a personality and a life to it. That's just coming up 1 year from now. Yes, when it was discovered in 1930, famously by Clyde Tombaugh, and I think Paul has prepared some images of when it was first discovered for us to see. Everybody was very excited. A year later, Walt Disney decided that his only non-speaking character, there was only one that didn't have a speaking role, this dog that was named Rover in the first cartoon in which the dog appeared. Well, 1 year later, by 1931, Pluto, the planet, the newly discovered planet, had such global fame that the Disney company wanted to exploit this, and so they changed the name from Rover to Pluto, and that's one of the reasons that the public is so endeared with that name and so bummed by its demotion back in
I
2000.
know,
I
and Pluto
ask
was
about-
my favorite childhood character. I just want to butt in here a little bit, gents, because
Oh, yeah. Go ahead.
we are looking at this live image from the Canary Islands T2 high magnification telescope. Now, this telescope is superb at looking at planets. And we saw a little insert there of Clyde Tombaugh sitting at his blink comparator. Now, he wasn't looking at an image this good. He had to generate his images over hours of exposures on these 20-inch glass plates. And he put them in this machine and he had to compare them. There's the machine. It's a great looking thing. And you can see what he's faced with. Here we are with this modern view of Pluto. Which one of those is Pluto? Well, that's why he had to use this machine. He had to look at two different images taken over a period of time and blink between them. So the next image is just coming up. This is the next live image coming up. It starts off in black and white, then it goes to color. Now, I'm going to ask our producer if he can cut away and show the animation that I prepared of Pluto from last night, because this demonstrates to you how you can find these objects, and it demonstrates to you as well how Clyde Tombaugh found this, but also how the big surveys which are looking for near-Earth asteroids are hunting for them now. So as we wait to have a look at those, Bob, you've been to the Lowell Observatory and you've seen this machine. I mean, this guy had dedication, didn't he?
Yes, yes. I was just there a few weeks ago, and it was wonderful. The plates were taken in January of 1930. The image, the planet was discovered in the middle of February, but they held off the announcing that it was a new planet until March 13th so that it would match the discovery date of Uranus back in 1781, which was announced on March 13th. They thought that would be kind of cool to do. And as for the name...
Yeah, let me just pause you for a second. For those who don't understand exactly, why would blinking allow you to know that there was a planet there?
We're going to see that
Well,
when this animation comes up. Here it is. Here is the animation. You can see it. This is 3 images, right, in the animation, and you can see it moving very clearly. Now, that's taken over 3 nights. That was taken with the same telescope that we're looking at tonight, and that's the only way you can tell Pluto, because it's moving so slowly when you actually just look at it in one image. But as soon as you start turning it into a time lapse and blinking between the 2 images, you see it better. Now, actually, Bob, we are having more difficulty spotting Pluto at the moment than Clyde Tombaugh did, and that's because Pluto is currently in the constellation of Sagittarius. So maybe you can explain to viewers why we're seeing so many stars in this image.
Yes, when we look towards Sagittarius, we're looking towards the center of our own galaxy. So it's so crowded with stars. When it was discovered, actually, when it was discovered, it was in Gemini, which is also looking toward the center of our, which is also looking along the plane of the galaxy, but opposite to the center. So we're looking at a different part of the Milky Way galaxy then. What was I saying? I was in the middle of something.
Let me ask you to hold that, Bob, for just a moment, because
I can't hold it because I've forgotten it. But
okay, it'll come back to you. But we have some of our Slooh members who have been asking questions, and I should point out that one of the advantages of being a Slooh member, other than being able to command the telescope and sending it on its missions, is being able to be part of our community, and our members really do talk with each other via text all the time. That's especially good when they're looking at sort of specialty things in the sky, when one member can help another. And it's amazing if you're a new member who has a limited knowledge of astronomy and you want to find out more, because believe me, the Slooh members want you to be interested in astronomy. So if you have questions, there will be answers from our members. Meanwhile, they have questions for you two tonight, guys, and we're going to start with Jamie J., who has a question for Paul. And Jamie asks, if the normal live images Slooh members watch are in black and white, are they? But I think I've seen color, haven't I?
Good question. Well, we are looking at this color image at the moment, and Jamie is probably asking that question because a lot of our shows are on near-Earth asteroids, and we tend to see those in black and white because we need the deepest image to image the very faintest objects. But maybe our producer can actually feed in some of the images that Slooh members were taking earlier. We've got one of M16. If that one comes up, maybe Bob can tell us a little bit about that. But yeah, we often don't show some of the most beautiful images that Slooh members get to watch live, because don't forget that this color image is live. Now,
beautiful.
Bob,
Yes, this is the Eagle Nebula, the famous star cluster, and the Eagle Nebula, famously called the Pillars of Creation. But if you've seen that noted image taken at the University of Arizona by Jeff Hester and Paul Scowen, entitled The Pillars of Creation, we can tell you that that was created by these guys in Photoshop. This is the actual colors. This is the true color of the Eagle Nebula as seen by a Slooh member.
Yep, 2 hours ago. Well, it was seen by all Slooh members, because the great thing about Slooh is that you get to see what everybody else is watching as well. And that color image, Jamie, that's what Slooh produces live. So when you're watching this, you see these images come up. This is another one from earlier on. This is a waxing crescent moon. It's a shame we haven't got this full screen, because I'll tell you, this is a high resolution image and you can zoom in on that, and Bob, you feel like you're flying over the top. Of course, this is a great time to be observing the moon when you've got the Terminator, all that lovely shadow there. And I think we've got one other image to show Jamie from earlier on tonight. Back into the solar system, that's where we are tonight with Pluto, Vesta and Ceres. That was the live image that Slooh members looked at earlier on tonight. Bob, how about that one? That's a bit unmistakable, isn't it?
Unmistakable and very impressive, considering that Saturn is now so low in the sky and more challenging than it was a few months ago. This is gorgeous. Look at that. You even see the shadow that the body of Saturn is casting to the upper left on the rings themselves.
Yeah,
so Jamie,
points. But let me just
Sorry.
bring this up really quickly, Paul. A couple of important points that you guys brought up, and one of them is that you can sort of eavesdrop as other members are setting the agenda for the telescope. So if you do not have a mission that's going on, you can watch someone else's mission. That's right, Paul. And a lot of people do that, right?
Yeah, absolutely, all night long. And of course, when we've got the Chile Observatory open as well, that extends the hours. We're open for, yeah, that's for a solid 14 hours, I think, 12 to 14 hours. So, yeah, and everybody can watch everybody else's missions, and you can snap images to collect them and stuff like that. Anyway, I think there was some more. Oh, there's that lovely image. That's from the half-meter telescope.
Way,
I love that half-meter telescope.
The Terminator,
Sorry,
the day-night line taken by this Slooh member, just happens to be passing right over that initial landing site of Apollo 11. That's where it is tonight.
Wow.
The Terminator is over the landing site, so we're seeing that as well as it can ever be seen.
So,
Jeff,
Paul,
did we get any more questions?
We have these. Yes, we do. But I have one more really quickly before we go on. When we see these images, like the image of the moon, we're obviously limited in the resolution that we can show when we stream a video program like this. What's the resolution that users of the Slooh telescope get to see in these images?
I can't answer that simply. It depends on the camera that we're using and what's called the binning level that we use, which is probably a bit too technical. It's a large range of resolutions depending on the object type and camera used.
But it would always be more than what we can show right now on this video feed, right?
Oh yeah, because this is streamed video, so you always lose something in the streaming back from the observatory, the streaming up to the show, and then down to people's monitors. So yeah.
All right, Bob. Let me ask you the question of the night. You know, we're talking about Pluto, and it's been a big deal. I grew up all my life. Pluto is a planet, and now Pluto's not a planet. So Anna Taylor asks, what, Bob, is your personal opinion of Pluto's demotion to a dwarf planet?
Ooh, good one.
Oh, Anna's not going to like this. She's a fellow palindrome like myself, meaning her name is the same backwards and forwards. So I hate to go against the grain when somebody like that asks a question. And the public is very much against Pluto's demotion, but I have to tell you, it was really the right move. And the reason for that is that we started finding more of them. We found that Pluto is not the largest object out there. There is Makemake and Eris and Sedna and too many others. And so all of them, if Pluto remains a planet, they all have to be planets. And soon we're going to have 40 and 80 and hundreds of planets. And, you know, that wall poster that you had when you were a kid, Jeff, and you had the 9 planets and you could learn them all, would you have learned them all? Would you have bothered if there were 200 of them? Probably not. So 2 choices. We either make a separate category for Pluto and all these other bodies that are very much like Pluto. Strange orbits, highly tilted orbits, tiny bodies smaller than our moon, icy, very different in characteristics and in orbit from the others, from the classic other 8, make them into a separate category, or call them all planets, in which case you're going to have 8 that are very similar, the 8 big ones have similar orbits, and then you're going to have hundreds of them that are these little tiny pieces of garbage out there, and that just didn't seem to make a lot of sense.
All right, before we get to our last question, let me remind everybody what you're seeing on the screen. Shows like this happen, well, they happen when we have events to look at, like tonight's opposition of Pluto, and also the ability to look at both Vesta and Ceres in the same telescopic field. If you'd like to be tipped off to those, please sign up, and we'll send you an email when we're going to be on live doing these. Go to our website, live.slooh.com. That's live.slooh.com and sign up for email alerts. All right, guys, one more question, and you two can decide who of the two of you is the best to answer this. This is from Lorraine, who said, I was watching live images earlier and saw 2 bright lines in one of the asteroid images from the half-meter telescope. Were these a meteor?
I
Were they, guys?
I was watching that same mission, and astrophotographers and Slooh members curse these when they happen. You're looking at a beautiful, beautiful image, and suddenly there's this great big white streak going through. But this was unusual. I don't know if our producer can actually pull this up from earlier on, but it was that same image that we were looking at with the half-meter telescope, with Vesta and Ceres traveling along with all of those beautiful galaxies in that galaxy cluster, and there was one big white line going over here, and there was a shorter white line at the bottom of the image. No, they weren't. There you go, we can see it. Yeah, no, that's not a meteor, that's a satellite. And in that particular image, if we could see it a little bit bigger, we'd actually see the second line that we saw as well. So, Lorraine, it's a satellite, not a meteor. But that makes it just as interesting. Actually, Jeff, there's a group in the clubhouse, which is where members hang out, which are they deliberately hunt down satellites and try and catch them in these images. And they especially go for all of the spy satellites and those that aren't listed. So that's fairly cool thing to do with the telescopes as well.
Paul, is the reason that it looks like a dotted line because the satellite is sort of tumbling and is not always showing the same reflectivity back toward the Earth? Or is this just part of the way we image it?
There you go. Yes, you're right. I'm glad our producer managed to get that going slightly larger. And yes, you're right. It's a combination of two things there, actually, Jeff. One is that it's going diagonally across the pixels, so there is a little bit of that. But yes, you're right. These satellites do actually tumble, and quite often you'll see one flashing on and off. So it's a very defined dotted line going across the image.
Yeah, and the images are beautiful. I mean, some of what we saw tonight really is breathtaking. Listen, we're going to wrap it up right now. Let me just come back to you two, and let's see if we get any final thoughts on tonight. Some takeaways that you can give our viewers tonight. We'll start with you, astronomer Bob Berman. Go ahead.
Well, I'll never forget those two minor planets or asteroids, Ceres and Vesta, passing in front of a galaxy field, both together. Or Paul's magnificent animation that he produced just from images a few hours earlier, showing these bodies speeding in sync. They actually are almost the same distance from the sun, about 2.5 times Earth's distance, and they both have periods, similar periods. Vesta takes 3.5, and Ceres takes 4.5 years. So they're marching in sync with galaxies in the background. You know, one of those great moments. We've had so many over the years here with Slooh, but I won't forget that. And I don't think I'll forget looking at Pluto either, seeing it march slowly in front of the background stars and knowing that exactly a year from now, no longer will it be an unknown dot. For the first time, we'll have sent a spacecraft, and now we'll have something to sink our teeth into. We'll have images, we'll have pictures of it. So this is the final time, my friends, that we're looking at it as a dot, and that's going to stay with me too.
All right, Paul, why don't you give us your final thoughts for tonight?
Well, I can never top Bob, of course, Slooh's astronomer in the astronomy stakes. So I think I'd have to go for, first of all, what a fantastic surprise that Vesta and Ceres were heading into that galaxy cluster. That was such a lovely bonus in those live images we saw tonight. And the only other thing I'd say is, you know, if you want to get into astronomy, but you're a little bit afraid because it's a big, complicated science, it's not. Come in, join us in the Slooh community, and we'll teach you not only how to use the telescopes, but everything you want to know about astronomy. And just for Slooh members, go into the clubhouse tomorrow, because I'm actually going to be showing you how to make those animations that we looked at tonight.
Oh, the one where we watched Pluto move through the star field?
Yep, I'm going to show people exactly, and you can get the software, the free software. So go into the clubhouse tomorrow, the Slooh clubhouse. I'm going to show you exactly how to do it in a video, and you'll be able to download the software and do it all yourself. All
right. Well, let me finish by talking just briefly a little bit more about Slooh. Slooh is the community observatory. We use the word community very, very freely because that's an incredibly important part of what we do. Slooh maintains 2 observatories, one in Chile, one in the Canary Islands, multiple telescopes in the Canary Islands. These are wonderful, very expensive, very well sighted instruments that give our members a chance to see a lot of really spectacular views in the nighttime sky. And Slooh has two main purposes that you need to think about if you're thinking about joining us as a member. First of all, our Slooh members control the missions. In other words, the Slooh members decide individually where the telescope is going to be pointed. And as a Slooh member, you have access to set up these missions. That's number one. Number two, as Paul was saying just a couple of minutes ago, we have an extremely active membership base in the clubhouse. And we have specialty groups. As he said, Paul said that we have people who look for satellites, we have people who look for comets, we have people who look at asteroids, and of course we are participating with NASA in the Grand Asteroid Challenge. That is a wonderful part of Slooh. And if you're someone who wants to learn about astronomy, who the nighttime sky has fascinated, then Slooh really is the place for you. We have our observatories in places where the sky is very dark, where the clouds are infrequent, and where your investment doesn't have to be in the tens of thousands of dollars. It's much less, obviously, on a monthly basis. So we'd like you to take a look at slooh.com. We love bringing these broadcasts to you. I can't begin to tell you how much Paul and Bob and myself are glad that you're here looking and that we have a chance to show you some really cool things in the nighttime sky and some really great things that the Slooh telescopes can bring to you. So thanks for joining us this evening on behalf of astronomer Bob Berman and also our observatory director and community director Paul Cox in Britain, where they will not be celebrating the 4th of July. Have a very, very good night and a great weekend. I'm Jeff Fox. Thanks for joining us.
except this was by an Italian, Giuseppe Piazzi, except the next year they found another one. Heinrich Olbers, the guy who's famous for Olbers' paradox, why is the night sky dark, found one. Then they found another one. Then they found another one. They realized, hey, wait a minute, there's a whole bunch of little planets there. And that was the asteroids. And of the four big ones, there's only four big ones and thousands of little ones, two of the four are passing close together tonight in the constellation Virgo.
So,
Absolutely.
Paul, this is a big deal at our observatory because we've got these two asteroid and a minor planet together, right?
We've got them in the same field of view. So now's a great opportunity. We'll show viewers some animations I made earlier, which will show them which of these white dots are the asteroids. And if we can bring those up now, if our producer can bring those up, we've got an added treat tonight, Jeff. We've got both Vesta and Ceres in the same field of view in our half-meter telescope as a galaxy cluster. It's absolutely beautiful. Hopefully we can pull these images up fairly soon, and I can point out to you which of the objects is Vesta and Ceres. While we wait for those, Bob, there's a huge confusion, isn't there, between all of this terminology between a dwarf planet, a minor planet, near-Earth object, near-Earth asteroid, comet. Can you give us a little bit of clarity on some of those definitions?
For the old days, Paul, when everything was simple and these were simply called asteroids, meaning looking like stars.
I'm going to interrupt. I'm going to interrupt
yes.
Because we've got these animations that I made just a couple of hours ago. So these are from the live images. And when we go to the live images, when we start talking about this in more detail, you can see the two dots that we're looking at, the dwarf planet Ceres and the asteroid Vesta. And these two Slooh members have been watching these two, Bob, getting closer and closer together every night. Now, we've got an absolute treat. We're going to be looking at images from the half-meter telescope now. So if we can flick over to that image, because we've got still Ceres and Vesta showing up, moving across the field of view of the telescope, getting closer and closer. But if you have a look at the bottom of those images, you're going to see that both asteroids are heading straight towards a beautiful galaxy cluster. And this is just a coincidence, an absolute coincidence. So our producer will get that up while Bob and I talk a little bit more.